So now we're going to tackle the idea of percentages. And as you've been seeing in this module so far, the goal is not to teach students some prescribed strategy like looking for keywords, and if you see this keyword, then do that. No, the idea is let the meanings, let the understandings drive what you do. And here's the key meaning or the key understanding you're going to need to allow this problem to emerge, the mathematics of this problem to emerge, and that is this. Percent means per hundred. Cent is a prefix for 100. Imagine, 100 cents is $1. So a cent is 1/100th of a dollar. It's like a percentage. We think of century as 100 years. So cent is used in the idea of 100. So per cent means per or out of 100. So with that one meaning, I'd like you to think through this problem. Now, this context I've chosen is for you all as adults. When you teach students and you want to have some mathematical idea emerge from a context, you might have to choose a context that students can relate to, that your students can relate to. I'm hoping that you can relate to this context, and the context is you have had some service done, maybe an electrician or a plumber, or I don't know, some kind of a service done that you would use, you would give a tip for, and in this case, a gratuity of 18%. So 18% gratuity turned out to be $150. What was the total cost of the service? Now, let's not go through like, hey, when you see of, it means multiply. When you see is, it means equals. And when you see altogether, it means not keywords. It's just thinking about what these ideas mean, and that'll inform me what to do. Let me try to unpack it. Here's my thinking. So 18% means 18 out of 100. And so 18 out of 100 amounted to $150. Now this is where the 100 squares come in. 100 squares is a great visual tool to help students see what's happening with percentages. Each square, since there's 100 squares, each square represents 1%. Can you imagine? I won't write them all in, but can you imagine 1%, 1%, 1%, 1%, 1%? Each individual square represents 1%, and all 100 squares would therefore be 100%, and we know that 100% represents the one whole unit. Now in my case, the one whole unit is the cost of the service. So all 100 squares would be the full cost of the service. 18 of those squares, 18%, so 18 out of the 100, let's see, where would that be? There's 10 across, 11, 12, 13, 14, 15, 16, 17, 18. 18% would be right here. If you put 1% 18 times, 18% would be right here. So 18% represents $150. So in these 18 squares, there is a total of $150. And what I want to figure out is how many dollars would be in all 100 squares, the full 100%. Okay, so how much money would be in 18 of the squares? $150. Therefore, how much money would be in each square? So $150 would have to fit in 18 of the squares. So if I took 150 and equally split it up into each of the 18 squares, hey, that's division. Do you see what I'm trying to get at here? I'm trying to mimic the thinking. Students are thinking, following their noses, and they're like, well, I need to put the $150 into 18 squares since it's 18%. That's a division problem. So 150 divided by 18 would be how much money goes into each of those squares. And 150 divided by 18 is 8.3. Give myself any room there, but it's 8.33, and the 33 repeats. So it's $8.33, but the 0.333 repeats, of course. So every one of these 1% is $8.33. Each one of these is $8.33. And 18 of them, if I filled in all 18 of them, would give me the $150. Just to kind of check it, if you took the 8.33333 18 times, you would get the $150. All right, so now we know that each square is worth $8.33 in this case. $150 would be 18 of the squares. Well, what would 100% then be? What would the whole cost of the service be, all 100 squares? Well, if each square is 8.333 repeating, and there's 100 of those squares, I have 100 copies of 8.33333. What's 8.333 times 100? Well, it would be 833.33. So to the nearest penny, contextual here, we're talking about money. The whole service would be $833.33. Now, you can work kind of backwards now to check your work. Imagine all 100 squares is $833.33. How much would go in each square? Well, if you took 833 and 33 cents and divided it by 100, you would get the 8.33333, of course. And then if you did 18 of those, because you did 18% tip, 18 of those would be the $150. Notice the rounding here because of our 0.333. The 1/3 kind of makes this a little trickier with money, but you can hopefully see the idea. So that's it. We allow meaning. What does 18% mean? We allow the tool to help me make sense of it. How much would be in each square if 18 squares is $150? And if each square is 8.333, how much money would be in all 100 squares? 833.33. The meaning drives my thinking, drives what computations I should do, and I can solve this problem. Now, of course, we want to get to algorithms, but for now, let's not hurry, let's not rush to the algorithm. Let's let the thinking emerge first. Keep going through the cycle. You'll see how we'll drive towards the efficiency of this all.